Hello and welcome to our team project demo, which goes over how to do edge detection in Python. So as you can see open in Spider, we have two different files that we use for our edge detection program. The first one is a functions file. So this is a module that we've created that we're going to be calling upon to execute the edge detection. And so we have functions defined for reading in the image, the grayscale conversion, the Gaussian filter which blurs the image, the Sobel detection, which detects the edges themselves, the Laplacian filter, which refines those edges, and then the thresholding at the end. And so all these functions are predefined in this file, and then over in our main method, or our main file, we call all of these functions and see what they output. And so the image that we're going to be looking at first today is lena.png, a classic in computer vision edge detection. And so we can see up here we have some basic error checking loops and whatnot at the beginning of our program, and then we go through and run all of our functions one by one, and we can see what they output one by one as well. And so if I run this program, the first thing that it's going to do is ask me to enter a .png file. And so if I enter something invalid, let's say I type Lena and I forget the .png, then it's going to send me right back and ask me to enter another .png file. If I type exit in all caps, then it'll just end the program. So if that is something the user wants to do, they're able to. If I enter a valid input that's in my directory, so lena.png, it is then going to ask me to enter the thresholding value. The threshold is a user inputted value that we use in our edge detection because the threshold is going to change depending on which image we put in. And so usually for Lena, around 50 is a good threshold that works pretty well. The Laplacian filter is an option for the user whether or not they want the finer edges. So for now, I'm going to say no and come back to it later. And so as you can see, we have outputs telling us when each step of the function is completed. And so right now it says that the image reading and the grayscale conversion and the Gaussian suppression are complete. It's running through Sobel and thresholding, and there is our output at the very end. And so you can see it displays all of them one by one. You can go back and check our plots and look at sort of the progression. And in addition to seeing them within Spider itself, we can open up our directory and see all of these pictures saved as images. So this is the final output of lena.png after running those steps of edge detection. Now another feature of our program is the option to include the Laplacian filter, which is a filter that uses the second partial derivatives with respect to x and y in order to refine the edges that we see in this picture, because a lot of these edges are a lot thicker and darker than we might expect. And so if I ran this again, and this time I decided to include the Laplacian filter, it basically runs through the same process, but in between the Sobel detection and the thresholding, it's going to add in this Laplacian filter method. And what we're going to see are much sharper lines at the very end of the program in the output. And so we can sort of see the same picture, but it looks a lot more detailed. And you can see the eyes a bit more clearly and a lot more of the nuances in the picture. Although it does sort of get rid of some of the edges that we may have wanted to keep. And so there are other methods that exist to fix that, but we aren't going into those in this video. So one thing to note is that lena.png is a file that only has RG and B values inside of its matrix, but we also want our code to be able to work with RGBA files, or files that have 4 two-dimensional arrays stacked on top of each other rather than just 3. And so one such file that we have is coins. Coins.png actually is an RGBA PNG file. And so we can go through and run the program again using coins instead. Set our threshold. We're going to neglect to apply the Laplacian filter for this. And it's going to run through the entire process one more time. And there we can see that it did the same thing and found us the edges of the coins. And if we go into our variable explorer and we look at the image itself, we see that this is a 4-column matrix and it still works as intended. So that about wraps it up for the demo of our edge detection. We've included comments for the user at every step of the way, and the functions are a little bit less efficient than they could be, and that's because we use more traditional methods, and so this would be exponentially faster if we had used OpenCV or SciPy or some of the libraries that already have edge detection built in. But this is our project, so thank you very much.